I'm happy to be one of the leading collaborative investigators within the NEPTUNE program funded by the Office of Naval Research.
The NEPTUNE project is a Navy-funded project to help get veterans involved with energy research that can again be used for a variety of different things.
Within the NEPTUNE program at Arizona State University, we have several professors that are engaging in advanced energy research and training. What we do within my group is focused on microgrids, both in terms of the design of microgrids, the installation of microgrids, then how do you make those intelligent and smart so you can take multiple microgrids and then hook them together to make a larger whole that's more resilient, more reliable, and lower costs. Involved in that work as well, we have 3 different training programs. The first of those is grid operator training. So once you've installed a microgrid, how do you operate it? And that's in a partnership with INCSYS as well as with Power Data, so you get the real-life experience of acting in an operator controller much like you would see in the movies. The second one of those training, and what we're doing this week, is a Microgrid Bootcamp. That's focused on the design of microgrids for technical and economic optimization, but then also the hands-on implementation integration. The third of those training programs is Island Energy Solutions, and later on this summer we'll be going to the country of Aruba to look at island energy solutions in a very tight-knit, constrained setting. That's much like in a playground to think about policy, economics, technology, and innovation. The participants get together for that 1 week and then engage in the initial comparison of different energy options: PV, water, hydro, wind, different types of batteries, generators, and then you take what is the most economically viable out of those, a subset, and then do the electrical engineering analysis to make sure everything is safe, stable, etc.
So you can really only do so much research online. You know, everyone's got access to the internet now, but it's not till you actually dive into a focused group like this with, you know, a very an educated instructor that you can actually start asking the questions and seeing the intricate parts of the system.
In this boot camp, the most interesting part to me has been the data analysis, the data gathering, how you can use that for optimization purposes, some of the software we've been using that shows this certain mix of renewables is going to be your best bet both financially and as far as energy production.
And then after you've designed that, then we go out and then we integrate. How do you safely hook up PV panels together? What does an inverter do? How do you safely manage and operate battery systems, generators, etc.?
Being able to do this boot camp was great because I got to see hands-on what you actually get to, you know, how to build the solar setup, how to do a microgrid, and being able to touch and physically feel something is a better way of learning for me.
One particular project that we built in a partnership with NRG Renew is a containerized microgrid. And so we pack everything together: solar panels, batteries, the inverter microgrid controller, and then also a generator, and that goes into a 20-foot shipping container. And so that 20-foot vessel, 20-foot cargo container, is intended to be rapidly deployed for disaster response or other civilian or military application.
The container was incredibly interesting because it's so portable and so all-in-one and can be deployed to areas that have been impacted by these significant like hurricanes, earthquakes, tsunamis, that sort of thing, where necessarily you can't set up a more permanent area or the permanent services you have been wiped out. So you can bring in this container. It's very user-friendly so that people who are in that area don't need an extensive amount of training in order to utilize all of the components.
The goal of that device is to increase the longevity in a disaster situation where you might not have access to a ready supply of diesel or gasoline, to increase operational time by as much as 50% or 100%, or provide pure autonomy if you supplement that diesel and gas generation with other types of renewable fuels. And so right now today, the students are out at the site plugging things together, understanding about battery state of charge, how to efficiently and technically operate it, set up, deploy, and the entire system is deployed in under 2 hours. Right now we're collecting data. We'll take a look at it this afternoon, compare the physical data against our simulations, and continue the learning process.
Being still an undergrad in an electrical engineering program, not knowing, there's hundreds of careers that I could go into with just electrical engineering. but being able to see a couple examples of one, being able to actually go to a facility site, being able to see different projects and research and work, the fact that we're going to be going to an APS control room, all different aspects of a same degree field that you could go into several different careers with, and that's really helpful.